So the goals for today: use the tests for parallelograms to determine whether quadrilaterals are parallelograms. And there are multiple ways that you can do that. So conditions, here we go. If a quadrilateral has each pair of opposite sides parallel, then automatically that makes it a parallelogram. So if you can prove that the opposite sides are parallel, then you have proven that you have a parallelogram. This is not the only test, however, that can be used to determine if a quadrilateral is a parallelogram. We're going to have many different ways of doing this. One way, listen up, guys. One way is to show that opposite sides of a quadrilateral are parallel. If you can prove that, you have a parallelogram. There are other ways that you can do this as well. If both pairs of opposite sides are congruent, then it's a quadrilateral. Or sorry, then it's a parallelogram. So you only have to do one of these, by the way. You don't have to do all of them. So if you can show that either the opposite sides are parallel using slope, that means that it's parallelogram. If you can show using perhaps the distance formula that the lengths of the opposite sides are the same, then it's a parallelogram. If you can prove that pairs of opposite angles in a quadrilateral are congruent, then it's a parallelogram. If you can show that the diagonals cut each other in half in a quadrilateral, the black ones. If you can show that the diagonals cut each other in half if they bisect each other, that means you have a parallelogram. Or if you can show that one pair of opposite sides, so like top and bottom, is both parallel and congruent, then you have a parallelogram. Three of these four things, the first three, by the way, theorem 7.9, 7.10, and 7.11, we talked about those three things yesterday. We just flipped around some phrasing. Yesterday, we said if you have a parallelogram, then the opposite sides are congruent. This one is saying if you have opposite congruent sides in a quadrilateral, that makes it a parallelogram. Yesterday, we said that if you have a parallelogram, then the opposite angles are congruent. Today, we're saying if you have a quadrilateral and the opposite angles are congruent, that automatically makes it a parallelogram. Yesterday, we said if you have a parallelogram, then the diagonals cut each other in half. They bisect each other. Today, we're saying if you have a couple of diagonals that go through a quadrilateral and they happen to cut each other in half, they bisect each other, that automatically makes it a parallelogram. We did not talk about this one yesterday. But if you can show that one pair of opposite sides in a quadrilateral is both parallel and congruent, then you can also say that it's a parallelogram. So let's start taking a look here. First question, is this a parallelogram?
Yeah.
Why? Yeah, opposite sides are congruent. So, yes. And we can just say OPP for opposite, 421. So, yes, because the opposite sides are congruent. Which of the theorems right above it says that if the opposite sides are congruent, then you have a parallelogram?
Theorem 7.
That one's opposite angles. Well, opposite sides, congruent. 712 is one pair. 9, there it is, 7.9, yeah. 7.9, that is the theorem. It's the first one for today's notes. Theorem 7.9 is the reason why we can say that those side lengths make a parallelogram. All right, questions about that? This is kind of the basics of what we're doing today. Figure out if it's a parallelogram, say why, what theorem are we using to make that statement. So turn the page, here we go. Example 2. We'll get to talking about an eraser. So you can use conditions of parallelograms to find missing values that make a quadrilateral a parallelogram. So basically, if this is going to be a parallelogram, what does the value need to be? That's the kind of thing we're looking at today. So if you have an eraser that is brand new, apparently, this has never been used. If it had been used, it would be all kinds of beat up. The top of the eraser appears to be a parallelogram. Find the values of X and Y so that the side of the eraser is a parallelogram. So basically, what do X and Y need to equal to make sure that this top of the eraser is in fact a parallelogram? So we know in parallelograms that if it's going to be a parallelogram, then the opposite angles have to be congruent, meaning this 4y plus 4 has to be equal to the 5y minus 26. Likewise, the 56-degree angle needs to be equal to the 7x degree angle over here. So in terms of the values of X and Y, that would make this an actual parallelogram. We'd have to set them equal and solve for Y and solve for X. Now, which of the theorems from the previous page are we using to make this happen? 7.10, yeah, that's the one that says that if you have a quadrilateral and the opposite angles are congruent, then you have a parallelogram. So it sets it up for us, right? Find X such that 7x equals 56. 7x equals 56, divide by 7. What's 56 divided by 7? 8. X equals 8. It's the same math that we did yesterday. Then, if Y is going to be part of this as well, which it needs to be, then those opposite angles also need to be congruent. So that means that 4y plus 4 would have to equal 5y minus 26. So if we do this just right here, let's go ahead and subtract. I'm going to subtract 4y from each side. Because if we subtract 4y from 5y, that'll just give us y. And then if we add 26 to both sides, what's 4 plus 26? 30. So that's just the answer. Y equals 30. There we go. So when X is equal to 8 and when Y is equal to 30, the quadrilateral is a parallelogram. Those are the values of X and Y that would make that a parallelogram. So instead of saying this is a parallelogram, solve for X and Y, it's saying, hey, if this is going to be a parallelogram, what do the values of X and Y need to be? It's the same math that we did yesterday. It's just a slight tweak on the way the question is being asked. All right, let's keep going. Mosaics. The mosaic, there it is. The mosaic pattern of the floor is made up of different tiles. Part A, find the values of X and Y so that the tile is a parallelogram. So this time, we're looking at angles or sides here? Sides. Okay, so which theorem is being used? 7.9. 7.9 says what? So if both pairs of opposite sides are congruent, then it's a parallelogram. So we're looking at A, B, C, or D here for the theorem. A, yeah. So that'd be theorem 7.9, which would be corresponding to A there. Now let's go ahead and solve for X and Y. Actually, I'll have you solve for X and Y. Go ahead and do that one on your own. It's the same math that we just did for the previous problem. We're just using side lengths instead of angle measurements, but you're still setting things equal and solving for a variable. So. And I'm just going to do the math off to the left in the margin right underneath where it says study tip, but I'm not going to let you see what I'm doing yet. I want you to do it on your own first. Yes, it is. Okay. You can always check by plugging in to make sure it actually moves. Cool. What does X equal? 3. Because 5x minus 2 is equal to 3x plus 4. If you subtract 3x from both sides and you add 2 to both sides, that gives you 2x equals 6. 6 divided by 2 is 3, so x equals 3. What does y equal? 7, yeah. 4y minus 9 equals 2y plus 5. Subtract 2y from each side, you get 2y on the left. Add 9 to both sides, you get 14 on the other side. Divide by 2. 14 divided by 2, y equals 7. So, x is 3, y is 7. These problems are basically what we did yesterday. The next problems, though, is where things get a little bit more challenging. Like if you're just given expressions and you know that if you set things equal to each other and solve for a variable, you're good. That's all fine and dandy. However, sometimes you're not given that much information. Sometimes you're just given a quadrilateral on a coordinate grid, and you have to determine if that quadrilateral is in fact a parallelogram, and not just by looking at it. So that's why I put that qualify on there, not just by looking at it. So when we can use distance, slope, and midpoint formulas to determine whether a quadrilateral is in the coordinate plane is a parallelogram. Now, I would go ahead and alter this first sentence a little bit. Distance, slope, or midpoint formulas is how I would use it. You don't have to do all of them. You can do one of those three things. So my preference generally is to go with slope, because I find the slope formula to be the quickest thing, as opposed to distance formula. Now, this one is testing it appears to be the lengths of the diagonals, which is fine, because we saw a theorem that said that if a quadrilateral has diagonals that cut each other in half, if they bisect each other, then that means that the quadrilateral is a parallelogram. Personally, I would just test the slopes, because if this slope is congruent to that slope and the top slope is congruent to the bottom slope, then you have opposite sides that are parallel, which makes it a parallelogram. And because we're on a grid, finding slope on a grid is usually pretty simple. So that seems to me the quickest way to do this, but the book has other ideas, at least for now. So let's go ahead and do what they're talking about. So what theorem will you use to determine? Well, it's using the one about midpoints. The one about midpoints means that we're cutting things in half, which means we're talking about, what is that, 7.11 is the one that had to do with, yeah, diagonals bisecting each other. So this one is using 7.11 to do that. So it's finding the midpoint between G and J, which if you were to connect those between G and J, that would be a diagonal. And if you were to connect F and H and connect those, that would also be a diagonal. And if you had each of the midpoints of those two things being in the same place, that means they would be bisecting each other. So if the midpoint of GJ is the same as the midpoint of FH, then that means they're bisecting each other. They're cutting each other in half, which is a perfect valid way to figure that out. If they're not the same midpoint, then this is not a parallelogram, is what we're saying. So if you think about this for a second, let me get a pencil here. If you were to just go ahead and just quickly sketch in a diagonal between F and H and quickly sketch in a diagonal between G and J. If we are going halfway in between G and J, it actually sets up a lot of this for us. If we add the x coordinates together, -4 plus 2 is what? Or 4 plus -2, sorry. 4 plus -2 is what? Is 2. 2 divided by 2? 1. So the midpoint of GJ is at 1. Let's see. 2 plus -1 is 1. 1 divided by 2 is 1/2 or 0.5. So that means that the midpoint of GJ is at 1.5, 1 comma 0.5, which is right there. And right away, we can tell that's not the intersection of the two.
Wait, what is it?
What's that? 1 and then 0.5. So 4 plus -2 is 2. 2 divided by 2 is 1. Type it in again, because it should give you the right answers. 4 plus -2. Yeah, but you got to do the 4 plus -2 first and then divide by 2 after. Yeah. All right, so this next one, -2 plus 4 is 2, 2 divided by 2 is 1. 4 plus -2 is 2, 2 divided by 2 is 1. So the midpoint of the other one is at 1, 1, which is a little bit above it right there. Those are not the same coordinate. So when we're talking about diagonals of a quadrilateral for it to be a parallelogram, the midpoints need to be in the same place, which should also be the intersection of the two diagonals, which is, those are 3 different points on this one. The midpoints and the intersection are 3 different locations. So that is not a parallelogram. So right here, moving down below, if the diagonals of quadrilateral bisect each other, then it's a parallelogram. That's you, yeah. The diagonals of a quadrilateral bisect each other if the midpoints coincide, meaning the midpoints are at the same place, which also means it's the point of intersection. Because the midpoints of diagonal FH and GJ do not have the same coordinates, this is not a parallelogram. Now, the other way to do this would be, well, let's just try this one here. I personally would much prefer to use the slope method. If the opposite sides have the same slope, that means it's a parallelogram, which means we don't have to do any calculations because we're working with a grid. That's why I'm choosing this method, because it's, in my opinion, the easiest. So if we find the slope between A and B and D and C, those need to be the same. If we find the slope between A and D or D and A and C and B, those need to be the same. If any of those happen to not be the same slope, then it can't be a parallelogram. So here we go. Write this down first. Theorem. 7 point, which one says, actually, that's not even a theorem. We're just going to be using definition of parallelogram. So determine if it's a quadrilateral, and then it says justify your answer. So it says describe your method. Describing our method would just be using the definition of parallelogram. If opposite sides are parallel, it's a parallelogram. So we need the slope of AB. So I'm going to say slope, so lowercase m, and then AB equals. Here's the nice thing about this. Because it's on a grid already, we can just count. We don't have to do any math. So from A to B is down 1 and over 1, 2, 3, 4, 5. From A to B, yeah. Down 1 over 5, so that's a slope of -1/5. What's the slope of DC? -1/5, because it's down 1 and over 5. Okay, so those two opposite are same slope. So far, so good. DC, yeah, the slope of DC. Now we need the slope of DA. To get from D to A on that graph, what's our slope? 3/2, up 3 to the right 2. So 3/2. Slope of CB. 3/2. Are the opposite sides parallel? Yeah. So A, B, C, D is a parallelogram. So my personal recommendation is if you have a graph of a quadrilateral, and if it's asking you if it's a parallelogram, my personal choice is to figure out the slope of the opposite sides. I find that to be the quickest. There's no math involved, you just count. The least effective way, in my opinion, would probably be to use the distance formula to figure out if the opposite sides are the same length, because you'd have to use the distance formula 4 times. You have to find the distance formula for AB, for DC, for AD, and for BC. That would be kind of annoying. Yeah.
When you're doing fractions,
Yeah.
is y going to the top?
What's that?
Is y the numerator?
Yeah, so it's rise over run, right? For slope, difference in y over difference in x. Yeah. So if you go down from one to the other, it's a negative. If you go up from one to the other, it's positive. And then the denominator is always the number that goes from left to right. So that should always be a positive number on the denominator. All right. So again, my personal recommendation, use slope. Second most effective way is probably the midpoints, honestly, because midpoint formula is a pretty quick thing to do. Just add the x's, divide by 2, add the y's, divide by 2. And if it ends up being the same midpoint for both of the diagonals, then it's a parallelogram. So that's probably the second most effective way. In terms of angles, you can't really do the angle method on this one. So, all right. Almost done. Here we go. You can assign variable coordinates to the vertices of the quadrilaterals. Yes, we know that. However, actually, you know what? No, we're not even going to do this last example. That's it. Because this is a coordinate proof and we don't do coordinate proofs. So that's it for today. That's a pretty short lesson.